Can what you eat actually help stop colon cancer before it turns dangerous? I'm Dr. Angio, and today I'm going to walk you through the science behind colon cancer through a lens most people never hear about: your blood vessels, your immune system, and the hidden ecosystem in your gut that can quietly tip the odds in your favor. If you like evidence-based health breakdowns that help you understand what's really happening inside your body, subscribe, like this video, and leave a comment below. I post new science-driven videos every week so you can use knowledge as a form of prevention. Now, let's start with something that should stop you in your tracks. Why are we seeing colon cancer in younger and younger people? And when I say younger, I don't mean a little younger. I mean people in their 30s, people in their 20s, even rare cases in teenagers. Colon cancer used to be thought of as a disease that shows up later in life, so when that pattern shifts, it's not a coincidence, it's a signal. Here's what makes this so alarming. Overall, colorectal cancer incidence has actually declined for decades, dropping by roughly 1 to 4% per year since the mid-1990s. That sounds like good news until you look at what's happening under age 50. Early onset colorectal cancer, meaning diagnosed before age 50, has been rising by about 2% per year, and it now represents roughly 14% of all colorectal cancer cases. And in 2022, among people in the United States aged 20 to 49, colorectal cancer was the leading cause of cancer-related death in men and the second leading cause in women. The steepest increases are happening under age 40, where rates climbed from about 4.1 to 5.5 per 100,000 between 2013 and 2022. And this is not just a US story. Early onset colorectal cancer has been increasing globally since the 1990s, especially in high-income countries like Australia, New Zealand, and South Korea. And projections suggest that by 2030, about 1 in 10 colon cancers and 1 in 4 rectal cancers could be diagnosed in people younger than 50. So, when the pattern changes like this, it pushes us to ask a hard question. What has changed around us? What are we being exposed to? What are we eating? What are we not eating? And what is happening inside the body that makes a disease show up earlier? To understand why this is happening, we have to get clear on what colon cancer actually is. Colon cancer, also called colorectal cancer, develops in the large intestine, which is the lower part of your digestive tract. But your colon isn't just a passive pipe. It's living tissue that constantly renews itself. It's lined with immune cells. It's exposed every day to the leftovers of what you eat and drink. And it's home to a massive ecosystem called the gut microbiome, which contains tens of trillions of microorganisms that influence inflammation, metabolism, and immune signaling. That detail matters because colon cancer doesn't just appear out of nowhere. It develops in a biological environment. Over time, what's happening in that environment, your level of inflammation, your immune surveillance, the integrity of your gut lining, and the balance of bacteria living inside you, can quietly shape risk. Here's the uncomfortable truth: a large part of colon cancer risk is driven by repeated exposure. It's what the colon comes into contact with day after day, year after year. And when we look at the risk factors that keep showing up across study after study, a pattern emerges. Alcohol can raise risk, and the data is surprisingly clear. Even at moderate intake, each additional 10 grams of ethanol per day has been associated with about a 7% increase in colorectal cancer risk. Smoking raises risk too, and it's been linked not only to higher incidence but also higher mortality. And today, we also have to talk about vaping, because while many people think of it as a safer alternative, the chemical exposures can be complicated and in some cases harsher than people realize. A sedentary lifestyle is another major risk factor. Regular physical activity is consistently associated with lower colorectal cancer risk, while physical inactivity raises it. And this isn't mysterious. When we don't move, inflammation tends to climb, metabolism drifts off course, hormone signaling can shift, and the microbiome often becomes less resilient. Movement supports immune function, circulation, and gut health. Even a daily walk can nudge the biology in a better direction. Then there's diet, and this is where the evidence becomes especially strong. Ultra-processed foods matter. Processed meats matter. Red meat and processed meat intake has been associated with higher colorectal cancer risk, and one large pattern you see is that for every additional 100 grams per day increase in red and processed meat intake, colorectal cancer risk rises by about 12%. Processed meats have been classified as carcinogenic, and the reason they come up in colon cancer discussions is straightforward. They pass through the digestive tract, they sit in the colon, and they can create a chemical environment that promotes inflammation and DNA damage. Chemically, processed meats can lead to compounds like nitrosamines and other nitroso compounds, which can damage DNA. Heme iron in red meat can also promote the formation of cytotoxic and genotoxic compounds in the colon. And from a simple, practical standpoint, you're exposing the colon lining to these byproducts repeatedly over time. Now, one of the more telling signals comes from younger women in a long-running study called the Nurses' Health Study 2. Researchers found that women who followed a more Western dietary pattern, high in things like processed meat, red meat, butter, high-fat dairy, eggs, refined grains, had a significantly higher risk of early-onset, high-risk colorectal adenomas. And those adenomas are important because they're part of the pathway that can eventually lead to cancer. Another striking finding is that consuming 2 or more servings per day of sugar-sweetened beverages was associated with more than double the risk of early-onset colorectal cancer. So yes, these exposures matter. But what matters even more than any single risk factor is what many of them do inside the body. They tend to push the biology in 2 dangerous directions. They can increase chronic inflammation, and they can suppress immune function. And that combination matters because your immune system is one of your strongest defenses against cancer. Your immune system is not passive. It doesn't just sit there waiting for trouble. It patrols, it scans, it identifies abnormal cells and removes them before they become a threat. I want you to imagine it like a highly trained security team moving through your body at all times, watching for anything that doesn't belong, and that includes microscopic cancers. And yes, microscopic cancers are more common than most people realize. A tiny cluster of abnormal cells can exist without ever becoming dangerous. One of the most important concepts in modern cancer biology is that the body can hold these early abnormal clusters in check for a long time. Some researchers have described this as cancer without disease. The body contains it. The immune system may eliminate it. Or it may remain dormant. Oh, what flips the switch? What turns something microscopic and controlled into something dangerous and growing? One of the major tipping points is blood supply, and this is where angiogenesis comes in. Angiogenesis is the process your body uses to grow blood vessels. It's normal and necessary in specific situations like wound healing, pregnancy, or building the uterine lining. But cancer can hijack angiogenesis because cancer cells need oxygen and nutrients like any other living cell. Here's the key limit. A tiny microscopic tumor can only grow to about 2 to 3 millimeters in diameter, roughly the size of the tip of a ballpoint pen, before it hits a wall. Without its own blood supply, it can't keep expanding. No oxygen, no nutrients, no growth. But if angiogenesis gets switched on, if blood vessels start growing toward that tumor and feeding it, everything changes. In colorectal cancer, this blood vessel growth can arise early in the adenoma to carcinoma sequence, often through the upregulation of a signal called VEGF, vascular endothelial growth factor. VEGF acts like a biological grow signal for blood vessels by binding to receptors on the endothelium, the lining of blood vessels. And VEGF expression can be found in both colorectal adenomas and carcinomas, with especially high levels at the invasive edge, where tumors are trying to expand. And tumor blood vessels are not normal blood vessels. They tend to be thin, fragile, tortuous, disorganized, and leaky. They often lack the normal structural support you'd see in healthy tissue. They don't follow a neat hierarchy. They form a chaotic network. But even though they're abnormal, they still deliver what tumors crave: oxygen and nutrients. So, once a tumor gains blood supply, it can grow faster, invade nearby tissue, and eventually spread. That's why I sometimes describe it as blood vessels gone wild. It's not just growth, it's fuel delivery. And when fuel delivery ramps up, the whole disease process accelerates. This is why anti-angiogenic therapy exists. It's an approach designed to cut off the blood supply feeding a tumor. One of the most well-known examples used in colorectal cancer is bevacizumab, also called Avastin. Bevacizumab is a monoclonal antibody that targets VEGF. In simple terms, it binds VEGF and prevents it from activating its receptors on blood vessel cells. By blocking VEGF signaling, it inhibits tumor angiogenesis, which is one of the ways solid tumors support growth and metastasis. In the landmark trial that led to FDA approval, adding bevacizumab to chemotherapy prolonged median overall survival by several months compared with chemotherapy alone. Other analyses have shown benefits in progression-free survival, though the overall survival benefit can vary across studies depending on the population and treatment context. But the underlying point is consistent. If you can disrupt the supply lines, you can slow down the tumor's ability to grow and spread. Here's the challenge though, if we treat late, after a tumor has grown, built its blood supply, and potentially spread, achieving cure becomes much harder. And that leads us to a bigger question. Instead of only trying to cut off blood supply after the disease becomes dangerous, could we support the body's defenses earlier? Could we strengthen the internal environment so microscopic cancers are more likely to stay controlled or be eliminated before they ever gain momentum? This is where food and lifestyle become genuinely important, not as a replacement for medicine, but as a powerful partner to it. And it's also where one of the most exciting revolutions in cancer care comes into the story: immunotherapy. Immunotherapy is not chemotherapy. It's a treatment designed to activate your own immune system to attack cancer. When it works, the results can be dramatic. In some cases, immunotherapy can help people with advanced cancers, stage 3, even stage 4, produce deep responses that would have seemed almost impossible a generation ago. One major class of immunotherapy drugs is called checkpoint inhibitors. You may have heard of pembrolizumab, also known as Keytruda, or nivolumab, also known as Opdivo. These therapies work by removing the cloak that cancer uses to hide from the immune system. Here's what that means biologically. Cancer cells can express a signal called PD-L1, which interacts with PD-1 on T cells and effectively tells the immune system to stand down. It's immune evasion. Checkpoint inhibitors block that interaction, restoring the ability of cytotoxic T cells to recognize and destroy cancer cells. For colon cancer specifically, doctors often look for markers that suggest immunotherapy is more likely to work. One of the most important is microsatellite instability, often called MSI or MSI-high, and closely related to mismatch repair deficiency called DMMR. Tumors that are MSI-high or DMMR tend to accumulate DNA replication errors and produce abnormal proteins called neoantigens that make them more visible to the immune system. That visibility is part of why checkpoint inhibitors can be particularly effective in that subgroup. So, if you or someone you love ever faces a colon cancer diagnosis, one of the most important questions to ask is whether the tumor has been tested for markers like MSI and mismatch repair deficiency that could make immunotherapy an option. Now here's where this becomes even more interesting, because we're learning that immunotherapy response isn't only about the tumor, it may also be about the gut. The gut microbiome is not just digestion, it's immune education, it's immune regulation, it's inflammation control. And research has found that certain gut bacteria are associated with better responses to immunotherapy. One bacterium that comes up repeatedly in research is Akkermansia mucinifera. This matters because it suggests something powerful. The immune system and the microbiome are not separate, they're partners. Your gut bacteria can influence immune readiness, and immune readiness can influence your ability to control cancer. So, the next practical question becomes, how do you support a healthier microbiome in a way that supports immune function and lowers inflammation? One of the strongest tools we know is dietary fiber, because fiber feeds beneficial gut bacteria. Another is polyphenols, bioactive compounds found in colorful plant foods that help shape microbial balance and influence inflammatory signaling. And there's a particularly striking finding that helps connect the dots between fiber, the microbiome, and immune function. In cancer patients receiving immune checkpoint therapy, higher fiber intake has been associated with better outcomes in some studies. In one analysis involving metastatic melanoma treated with immune checkpoint blockade, People who consumed at least 20 grams of fiber per day had longer progression-free survival compared with those consuming less than 20 grams per day. The deeper message is not that fiber is a miracle drug. The message is that feeding the microbiome can influence immune strength in ways that matter for cancer biology. When gut bacteria ferment dietary fiber, they produce short-chain fatty acids like butyrate, propionate, and acetate. These metabolites don't just stay in the gut, they can influence immune signaling. Butyrate, in particular, helps maintain the integrity of the gut barrier and has been studied for its anti-proliferative effects on colon cancer cells. When the gut barrier is healthier, there's less inflammatory leakage into the bloodstream, and immune regulation can work more effectively. And the evidence for fiber in colorectal cancer prevention itself is substantial. Large analyses have found that higher fiber intake is associated with lower colorectal cancer risk, with some estimates showing meaningful reductions in risk in higher fiber groups compared with lower fiber groups. Whole grains, legumes, fruits, vegetables, nuts, and seeds are some of the most reliable sources, and they don't just deliver fiber, they deliver the polyphenols and micronutrients that help keep the gut ecosystem resilient. What's particularly interesting is that the impact of fiber may vary depending on your microbiome's capacity to convert that fiber into beneficial metabolites like butyrate. That means two people can eat similar foods and still have different biological outcomes based on what their gut bacteria do with those foods. And that's why the microbiome has become one of the most important frontiers in understanding cancer risk and treatment response. So now, let's bring this home in a practical way, because the goal isn't to be overwhelmed by mechanisms. The goal is to understand what strengthens your defenses. If we want to lower colon cancer risk, we want to reduce chronic inflammation, avoid exposures that suppress immune function, and support the gut ecosystem that keeps immune defenses sharp. That means lowering reliance on processed meats and ultra-processed foods, being mindful with alcohol, avoiding smoking and vaping, and moving regularly. Not because movement is a moral issue, but because movement supports metabolic health, immune regulation, and microbiome resilience. It also means building eating patterns that consistently deliver fiber and bioactives that feed beneficial bacteria and reduce inflammatory signaling. And yes, there are specific foods and beverages that repeatedly show up in research around colorectal cancer risk, inflammation, microbiome support, and immune health. Coffee has been associated with lower colon cancer risk in multiple studies, and both caffeinated and decaffeinated versions show signals of benefit, suggesting it's not just caffeine, it's also the bioactive compounds like chlorogenic acid. Tea, especially green tea, contains catechins like EGCG that have been studied for anti-cancer effects. Colorful plant foods like berries, deeply pigmented fruits and vegetables deliver polyphenols that nourish microbiome diversity. Cruciferous vegetables like broccoli, Brussels sprouts, kale, cabbage, and arugula contain glucosinolates that break down into isothiocyanates, compounds studied for their protective biology. Beans and legumes deliver fiber in a form the microbiome loves. Extra virgin olive oil contributes polyphenols like hydroxytyrosol and oleocanthal and fits naturally into dietary patterns like the Mediterranean diet that are associated with healthier inflammatory balance. Omega-3 rich seafood has also been associated with anti-inflammatory effects and has been studied for potential protective associations with colorectal cancer risk. The point is not to chase perfection. The point is to build a pattern that strengthens your terrain. Because modern cancer treatment is increasingly about precision and partnership, medicine targeting the disease and lifestyle supporting the internal environment that shapes your body's defenses. And I want to be very clear about this. This is not food versus medicine. This is food and medicine. Immunotherapy can be life-saving. Anti-angiogenic therapy can be life-saving. Surgery, chemotherapy, and radiation can be essential. But what you do outside the doctor's office still matters, because every day your choices either strengthen or weaken your health defenses. Colon cancer is one of the most common cancers affecting both men and women. And the fact that it's being diagnosed younger is a warning sign we can't ignore. But it's also a call to action because your body isn't helpless. Your immune system is designed to patrol and eliminate threats. Your body is designed to regulate angiogenesis and keep blood vessel growth in balance. And your gut microbiome can strengthen or weaken the environment that shapes inflammation and immune readiness. So the real question isn't only what causes cancer, the real question is what strengthens your defenses against it. And a major part of that answer is what you do every day, how you move, what you avoid, and what you put on your plate. I'm Dr. Angio. If this helped you understand colon cancer in a deeper way, subscribe, like this video, and share it with someone you care about. And if you want the follow-up, where I break down the gut microbiome in a more practical way, including how fiber, polyphenols, and everyday foods can help build a healthier bacterial ecosystem for immune strength, leave a comment and I'll cover it in the next episode.